Aloha everybody, this is Gigi from Kauai Community College. This is a video on composite functions. So for composite functions, we particularly are paying attention to the input and the output. Okay, so the composite function f of g, that's how you would read that, f of g. The composite function f of g is defined as a chain reaction, basically. So what you're going to do is, let's visualize how this works. You are going to start with the input x. That right there, that's the input x. Okay, what are we going to do? We're going to first insert that into the function g, and we will get out the output g of x. Okay, now what we're going to do with g of x is we are going to take that output g of x, that value there, and we're going to insert that right into the function f of x. Now if you take g of x and we are going to use that as an input to insert that into the function g of f of x, what do you think we're going to get out? F of g of x, right? F is our function and the input is g of x. And so we call the function f of g of x is f as the function. The input is g of x. So that is why we call that a composite function, right? It's composed of two different functions. And I would call sometimes this guy right here, g of x is the inside function in this case. And in this case, f of x would be my outside function. And that's what I would call them if you ever hear me talking about inside, outside. Here is an example. Suppose that f of x is equal to x squared plus 3 and g of x is equal to 2x. Okay, and we are looking for what is f of g of x. So again, we are going to start with x and we are going to put that into the function g. What are we going to get out? G of x. We're going to get out g of x. And g of x in this case is defined as 2x. So that is now my output, 2x. I put in x, I get out 2x. And what am I going to do with the 2x? I am going to place that as an input into the function f. So I will have f of 2x is the thing that I am looking for. And in order to find f of 2x, I would say wherever my input is, I would put in 2x. And 2x quantity squared plus 3 is going to equal to 4x squared plus 3. So f of g of x in this case is going to be 4x squared plus 3, as you see there. All right, so pay attention to input, output. What's the inside function? What's the outside function? All right, so suppose we are looking at f of x being x squared minus 9 and g of x being 1 over x. And we're looking for f of g of 7. So by definition, we would say that would be f being the outside function, g being the inside function, and the input is 7. So we're going to take 7 to start out with. And what are we doing with 7? Insert that into the function g. What am I going to get out? G of 7. G of 7, and g of 7 by definition of the function g, that would be 1 over 7. What am I going to do with the 1/7? Use that as an input into my function f, and I will have the output being f of 1/7. And what is f of 1/7? Wherever x is in my function f of x, I will go ahead and put in my input of 1/7, and that would be 1/7 squared minus 9, and that will give me negative 8 and 48 over 49, because this right here is going for 1 over 49. 1 over 49 minus 9. And that would be negative 8, 48 over 49. All right. Now we are asking, what is f of g of x? Same functions, just now in general term g of x. Okay, so again, the input is going to be x. What am I going to get out? G of x. And what am I going to do with this? I'm going to place that into f of x. But what is g of x now? G of x in this case is defined as 1 over x. So 1 over x being my input into here. So what I really have is f of 1 over x. And to find out what f of 1 over x is, I'm going to go ahead and put 1 over x wherever the input is. And I will have 1 over x squared minus 9 being f of g of x. Now, what if we go in reverse and ask you, what is g of f of x? Well, as you notice, you would say that would be g of f of x. G now being my outside function, and f now is being my inside function. What do you think? Is it going to be the same as f of g of x? Pause and wonder. All right, so let's answer that question. We are going to start with x. What are we going to do now? Not g anymore. We are going to place that into the function f of x, right? So what are we going to get out? F of x, and that will equal to x squared minus 9. And what are we going to do with x squared minus 9? Stuff that into the function g. And what we really are looking for is g of f. So this would be g of x squared minus 9 is really what I'm looking for. G of x squared minus 9. And that is wherever the input is in the function g, I will put in x squared minus 9. So g of f of x is 1 over x squared minus 9. So no, it is not the same as f of g of x. Now, if they are the same, we call f and g special functions that we are going to talk about in the later chapter. So pay attention to that, right? Not always the same when you reverse the order. Which one is inside and which one is outside. All right, here we go. Same concept. Pay attention to input, output, but here we're using a graph instead. Okay, so h of p of 1, by definition, it is h being the outside function, and the input function is p of 1. So we first need to find out what is p of 1. So input is 1 right here. Go up to the function p. We have p of 1 being 2. So this really is asking for h of 2, right? To find h of 2, what are we going to do? Go out to 2. And then look at the function h, which happened to just be right there. So h of 2 is 0. So this is 0. All right. Next, if we were to ask for p of h of negative 3, that would be, by definition, p being the outside function, and the inside is h of negative 3. Okay, so first let's go look. Input is negative 3, 1, 2, 3, negative 3. And we are first going to take a look at the function h to find out h of negative 3, and that is negative 5. So this becomes p of negative 5, and to find p of negative 5, I would go out to negative 5, which is here, and go up to my function p, and look for my output. And my output is 1, 2, 3, 4, 5, 6. So P of H of negative 3 is equal to 6. Here, same concept, but the functions are being represented by a table. What is f of g of 2? Well, by definition, the outside function is f of g of 2. So first, I need to go find out what is g of 2. So I need to go to 2 as my input. G of 2 is 0. That's my output when input is 2. So this becomes f of 0. Well, how do I find f of 0? Input is 0, go to the function f, the value is 4. And that's how that works. Okay, so make sure you pay attention to input, output. G of f of 1 is g of f of 1. So the outside function is g, the inside function is f. Let's go look at the input 1. Go to the function f. I have a value of 3, so I am now looking at g of 3. 3 is now being my input, so I'm looking at 3, and I'm looking at the function g, so my output is 3 for g of 3. What is g of f of 0? That is g being the outside function, f is the inside function, input of 0. So first, I'm going to go look at my table, go to 0 being my input here, look for f of 0, which is 4, so that becomes g of 4. Well, let's go look for g of 4. 4 being my input, 4 right here being my input, not in the table. 4 is not in the domain of this function, therefore this is undefined. So pay attention to input, output. Is that input in my domain? Up next, I just said the word domain, so up next we're going to study domain of composite functions.